Good to come your way once again. My name is Nana Yawedu, and you can call me Say Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In our previous lesson, we have looked at the factor and remainder theorem. We've considered how we can determine whether or not a factor, right, or a divisor is indeed a factor of a polynomial. So we said that when the polynomial function, right, we take the factor and then we equate it to 0 and substitute it into the polynomial function and then end up getting 0, then we can determine that indeed that is a factor of the polynomial function. In this lesson, we want to consider the method of completing the square in quadratic equations. So we want to look at how we can use the method of completing the square to solve quadratic equations. Now let's consider this. So basically, we say that the general form of a quadratic equation, right, can be written as as squared plus bs plus c is equal to 0, right? So we know that if we want to write it in an equation form, then we have as squared plus bx plus c is equal to 0. If it's a function, then it becomes f of x is equal to as squared plus bs plus c. Right, now we want to go through the process of resolving the equation using the method of completing the squares. Right, since this is algebra involving probably variables a and x, constants a and then variables s, it will look a little bit probably cumbersome, but then when you follow the process you'll be able to get it. And when we be able to situate that to real numbers, then it becomes easier for us. So let's consider how we can resolve this using the method of completing the squares. So first and foremost, we have our quadratic equation giving us ax squared plus bx plus c is equal to 0. So the first method we must employ is that we must, right, divide through, right, the equation. We must divide through the equation by the coefficient of x squared. So we want to divide through the equation by the coefficient of x squared. So that implies that we'll get as squared all over a plus bx all over a plus c all over a is equal to 0. So it means that the a will divide the a, we will get x squared plus b all over ax plus c all over a is equal to 0. Then, once we've been able to do this, we must move the constant across the equal sign. And we know the constant is c over a. So you are going to have x squared plus b all over ax, right, is equal to negative c all over a. Then the next step here, which is very crucial, is to take the coefficient of the x, which is b all over a, and then multiply by half, right? So it means that b multiplying 1 will be b, then a multiplying 2 will be 2a, and then we square it, right? So it's a process we do on the side, and then we add it to both sides of the equation. So we are going to have x squared plus b all over ax, right, plus b over 2a all squared is equal to minus c over a plus b over 2a all squared. So we've added it to both sides of the equation here, right? So once we are able to do that, right, by perfect squares, we are able to express the left hand side of the equation, right, as we pick the s term and then we put what is in the brackets and then we put the sign by it, right? So in this case it's positive, so plus b over 2a, and then we square them. So pick the x, pick what is in the bracket, right? If it's positive that is in the bracket, you add what the positive sign, then b over 2a, then you square them. What happens is that once we expand this, we should be able to get what is here, right? Once we expand this, we should be able to get s squared plus b over ax plus b all over 2a all squared. We'll see that when we are using the real example. So it's equal to negative c all over a. When we expand this side, we are going to have b squared all over 4a squared, right? So we can work the LCM for the right hand side, which we know is 4a squared. A will go into 4a squared, 4a multiplying negative c will be minus 4ac. Then 4a squared going to 4a squared 1, so plus b squared. So on this side we have s plus b over 2a all squared. Right, now we can write this as x plus b all over 2a all squared to be equal to, right, we bring the b squared first, minus 4ac all over 4a squared, right? So we want to eliminate the square, so we find the square root of both sides. So this cancels this, so we have s plus b all over 2a is equal to, right, the square root of, remember it affects everything here. So this side we can't do anything about it, so we have square root of b squared minus 4ac, right? But then when you look at the denominator, square root of 4 will be 2, and then square root of a square will cancel the square, right? So this square root will cancel the square here, so we are going to have 2a. So we can have our x, we have find the values of x, right? In completing square, we want to find x of a quadratic equation, so we want to find the values of x. So we'll move the b over 2a across the equal sign, or better still, we say we subtract b over 2a, right, at both sides of the equation. So we have x to be equal to minus b over 2a, right? We know the square root of an answer is positive and negative, so plus or minus square root of b squared minus 4ac all over 2a. Now LCM of 2a and 2a is 2a, so we have x to be equal to minus b, right, plus or minus square root of b squared minus 4ac all over 2a. And that gives us our values for x, right? So we get our values for x as minus b plus or minus square root of b squared minus 4ac all over 2a. So we've gone through the process to algebraically look at how we can solve for quadratic equations using the method of completing the square. In our next lesson, we want to look at some examples, right? And we'll use the method of completing the square to solve them. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget that always you share with others. See you in the next lesson.